This is area video number 2, and in this video I'm going to show you an example of when it would be better for you to set up the area problem by using a horizontal rectangle rather than a vertical rectangle. Okay, so here's our problem. We want to find the area that is bounded by the functions of, or by the equations y squared equals 1 minus x and 2y equals x plus 2. Okay, so again, just like we did in the previous problems, we're going to go ahead and sketch a picture of our graph. So for y squared equals 1 minus x, that's a sideways parabola, here with a vertex here at x equal to 1. And then for 2y equals x plus 2, that's just the equation of the line of y equals 1/2 x plus 1. So we'll have something that looks like this. Okay, and here is the bounded area. Okay. All right, so in the previous setup, we looked at this area and we said, okay, well, let's find the representative rectangle. And we came in here and we were able to sketch our rectangle, and we were able to find the base and the height of our rectangle. So here the length of the base would be a dx. The height of our rectangle would be y top minus y bottom, which would be the line minus the curve. Okay, well, here's the problem. Let's say our rectangle wasn't in the first position that I put it. What if I say my rectangle is over here? Okay, so now when I go to do the length of the base of my rectangle, it is dx. But when I go and I look at the height of my rectangle, my top curve is the parabola, my bottom curve is also the parabola. Okay, this is a problem. So we're not going to be able to set up our area problem by doing a vertical rectangle. Okay, so instead, what we can do is flip our rectangle the other direction. Okay, so it doesn't matter how you have your rectangles, as long as you have rectangles and you're able to accumulate a whole bunch of them. Okay, so if we take our rectangles and we flip them this direction, now, when we look at this particular rectangle, we have this side length. I'm going to still call this the length of the base. So this is going to still be the length of, this time it's not delta x, it's the change in the y values because we're traveling along the y-axis. So I'm going to label that as a dy. And now when I look at the height of my rectangle, my height now would be measured from this value of x to this value of x, which would be the same thing as taking this right function minus the left function. And since we are measuring these as values of x, what I'm going to do is I'm going to rewrite these functions in terms of x, so solved for x. So I'm going to have x right minus x left. So the x value on the right side minus the x value on the left side. And then the same thing will, everything will be the same then as what our other area problem setup was. So we'll be able to take the height of a rectangle, which is x right minus x left, and then we are going to take the length of the base of our rectangle, which is dy, and we're going to integrate. Now, here's the other thing. We are integrating with respect to y. So our y values are where we are accumulating. So we're stacking our rectangles this direction. We're going along the y-axis. So we are not integrating with respect to x anymore, we're integrating with respect to y. So that means that these values of integration, I'm going to call these c and d. so they're not confused with A and B from our previous setup, C and D are going to be y values. Okay, so let's go ahead and set this up then. First thing I'm going to have to do is if I want to get my height expression, I need x right minus x left. Well, my equations right now are almost solved for y. So the first thing I have to do is rewrite them in terms of x's. So I'm going to rewrite my equations. Okay, so for equation 1, I'm going to have x is equal to 1 minus y squared. And when I look at my picture, I see that that function, which is my parabola, that's my function on the right. So I'm going to go ahead and call that x right. For my other equation, 2y equals x plus 2, solving that for x, I'm going to have x equals 2y minus 2. And when I look at the picture of my graph here, I see that my line is the curve on the left. Sorry, the curve on the left. So I'm going to label that as x left. So now I have my x right and x left equations. All right, next thing I need to know is what are the values that I'm going to be integrating over. So in other words, I need to know what are my two intersection points of my two curves. So I'm going to go ahead and find intersections. So setting my two equations equal to each other. Let's see, we've already got them solved for x's over here, so I can just set those two equal to each other. We've got 1 minus y squared, and that's going to equal 2y minus 2. Okay, so now we're solving for values of y. I see I have a quadratic, so I've got to get this set equal to 0. So 0 is going to equal y squared plus 2y minus 3. This will factor as y plus 3 and y minus 1. And this will give me that y is equal to negative 3 and 1. Okay, so now in my graph, I'm integrating from y equals negative 3 up to y is 1. Okay, so now let's go ahead and set up our area equation. So area is going to be equal to the sum of all the rectangles. So I'm taking an integral. I am summing those rectangles over the y values from negative 3 up to 1. The height of my rectangles, we said, was x right minus x left. So 1 minus y squared. My x left equation was the line, so that was 2y minus 2. And we are integrating with respect to y. The length of the base was dy. Okay, so there's my area equation setup. So now I just have to do some computations here. So I take an integral from negative 3 up to 1. I rewrite my integrand, and I'm going to have a negative y squared minus 2y plus 3 times dy. And now integrating, we get negative y cubed over 3 minus y squared plus 3y. And we want to evaluate that from negative 3 to 1. Okay, now we go ahead and plugging in. We get, plugging in the 1 first, we get negative 1/3 minus 1 squared plus 3 times 1. And now we're going to subtract off, plugging in the negative 3. Here we're going to get a 27 over 3 minus 9 minus 9. Okay, and once we go through, add those all up, we end up with 32 over 3. Okay, so area is 32 over 3 units squared. Okay, so that is the general idea how you set up if you want to have horizontal rectangles instead of vertical rectangles. In the next video, I'll show you how to calculate the area when you have multiple areas formed by your two curves. We'll see you then.